learns. Now we are going through the topic requirements and specification. Requirements. Before we design a system, we must know what we are designing. This is the initial stage of the design process. Generally, it is having two phases. First, we gather an informal description from the customers known as requirements, and second, we refine these requirements into specification that contains enough information to begin designing the system architecture. Separating out the requirements analysis and specification is often necessary because customers can describe about the system they want and what architects need to design based on their interactions with the system. It may be unrealistic expectations as to what can be done within their budgets. Functional description is often not sufficient. So, the non-functional requirements. Performance. The speed of the system is often a major consideration both for usability of the system and for its ultimate cost. Approximate time to perform a user level function and hard deadlines by which a particular operation must be completed. Cost. The target cost or purchase price for the system is almost always a consideration. Cost typically has two major components: manufacturing cost and non-recurring engineering. Manufacturing cost, the cost of the components and the assembly, and non-recurring engineering, the personnel and other cost of designing. Physical size and weight. The physical aspects of the final system can vary greatly depending upon the application. A handheld device typically has tight requirements on both size and weight that can ripple through the entire system design. An industrial control system may be designed to fit into a standard size rack with no strict limitations on weight. Power consumption. Important in battery powered systems and is often important in other applications as well. Power can be specified in battery life. Customer is unlikely to be able to describe the allowable wattage. Mock-up. Validating a set of requirements is ultimately a psychological task. It requires understanding both what people want and how they communicate those needs. Mockup is one good way to refine at least the user interface portion of a system's requirements. It may use scanned data to stimulate functionality in restricted demonstration. It may be executed on a PC or a workstation. Requirements analysis for big systems can be complex and time consuming. Capturing a relatively small amount of information in a clear, simple format is a good start towards understanding system requirements. Requirement form. Requirement form that can be filled out at the start of the project. We can use the form as a checklist in considering the basic characteristics of the system. Contains name, purpose, inputs and outputs, functions, performance, manufacturing cost, power, physical size and weight. Name. This is simple but helpful. It can crystallize the purpose of the machine. Purpose. It should be a brief one or two sentence description of what the system is supposed to do. Inputs and outputs. It means the types of data characteristics, types of input-output devices. Types of data may be analog electronic signal or digital data, mechanical inputs, etc. Data characteristics, periodically arriving data such as digital audio samples or occasional user inputs, or maybe how many bits per data elements. Typicals of sorry Types of input output devices: buttons or analog or digital converter, video displays, etc. Functions: more detailed descriptions of what the system does. When system receives an input, what does it do? How do user interface inputs affect these functions? How do different functions interact? Performance: many embedded computing systems spend at least some time controlling physical devices or processing data coming from the physical world. The computer Types of input-output devices: buttons or analog or digital converter, video displays, etc. Functions: more detailed descriptions of what the system does. When system receives an input, what does it do? How do user interface inputs affect these functions? How do different functions interact? Performance: many embedded computing systems spend at least some time controlling physical devices or processing data coming from the physical world. The computations must be performed within a certain time frame. Manufacturing cost includes primarily the cost of the hardware components. Even if you don't know exactly how much you can afford to spend on system components, you should have some idea of eventual cost range. Power: similarly, you may have only a rough idea of how much power the system can consume, but a little information can go a long way. Most important decisions is whether the machine will be battery powered or plugged into the wall. Physical size and weight: you should give indication of physical size of the system to help guide certain architectural decisions. This is example for a requirement form for a GPS system. You can go through this for a simple requirement form. Specification: more precise, carefully written, and should be understandable enough. More precise: it serves as the contract between the customers and the architects. Specification must be carefully written so that it accurately reflects the customer's requirements and does know in a way that can be clearly followed during design. Specification should be understandable enough so that someone can verify that it meets system requirements and overall expectations of the customer. Designers may end up in different types of problems caused by unclear specifications. For example, a specification of GPS system: data received from the GPS satellite, map data, user interface, operations that must be performed to satisfy customer requests, background actions required to keep the system running, such as operating GPS receiver. These are the simple specification of a GPS system. The note: UML is a language for describing specifications. Thank you.